integral from 0 to 1, x times the natural log of x dx. I did u is x.
Well, wait a second. Could you just give me a second to tell myself where's my problem? 1 is okay because the natural log of 1 is
0.
it's 0. 0 is okay in there, but what about in the natural log? So the problem that I have is at 0.
Yeah.
And if you did this with all the nice stuff, we would be taking a look at the limit as a approaches 0 from the right, and you would turn this into a to 1 x ln x dx.
We wouldn't have to do u of ln x since we don't know the integral of ln x.
Yeah, I think u has to be ln of x, not x. Or maybe he said that. What did you do for your by parts?
I did x just because it becomes dx. It's easy.
I know, but how did you integrate ln of x? That takes its own integration by parts. I think we know what's the matter with yours. Yeah.
But it doesn't
Sorry,
derivative.
you're stuck.
That's a
No, that's the derivative. So dv here needs to be x, and v needs to be x squared over 2, and du is 1 over x dx. So your uv is 1/2 x squared ln of x minus the integral of x squared over 2 times 1 over x dx, which that you can now integrate. So this is a minus 1/2 x, which integrates to x squared over 2. So on the integrating part, that part's easy. We'll plug in the 1, so we get a 1/2, a 1, ln of 1 is 0, minus 1/4 times a 1 squared. So that totaled out to a negative 1/4. The a part, we're taking the limit as a approaches 0 from the right now. So that's a 1/2 a squared ln of a minus 1/4 a squared.
0 times negative.
This piece is easy because you can straight plug in the 0 and be fine. So that's gone. This piece is a 0 times negative infinity. This is a 0 times a negative infinity. And that's
Negative infinity.
no,
That's
it isn't.
undeterminate.
It's indeterminate.
Yeah.
It's indeterminate. So this was the one where you have to try to rewrite it so you can turn it into a L'Hopital's. So let's see.
What if we do like a fraction, the a to the square, make it a to the negative 2?
Sounds like a great idea. ln of a and a 2a to the negative 2.
So top goes to negative infinity and the bottom goes to
Okay, 0 from the right. The top goes to negative infinity. I agree. That one's going to negative infinity. 2 over a squared is 2 over 0. And that's going to positive infinity. But L'Hopital's doesn't care whether one's positive and one's negative, as long as you get an infinity over infinity. So we have to take the derivative -4
They're -3.
a to the -3.
So
Divided by 3. -3.
Yeah, and then we'll invert and multiply. I was just looking for a spot where I could go.
To the right.
It's a little limit, and it's 1 over a. This thing is -4 over a cubed, so it's -a cubed over 4. A goes into a cubed, so that's -a squared over 4. Oh, hooray! And as a goes to 0,
0.
it goes to 0. So this piece was 0. This piece
No, yeah, over here.
was, no, I needed that
Oh,
one too.
yeah, that one
That
goes.
piece went to 0.
Yeah, that one-
So I've really got a -1/4 minus a 0. So I hope the guy's answer was -1/4. Did you look it up? Shouldn't trust me. Did you look it? You really should look it up. Let's make sure that that's the answer. You won't be happy if you go home and it doesn't match.
What number is that?
41.
Yeah, it's -4.
Hot dog. So, I guess we need to write you a note that this was where we plugged in 1. Okay, so I'll say that. Substituted 1. And here was where we substituted the 0 by taking the limit, and then here's where we put the two pieces together.
You can do everything like a regular integral, except until you get to like the 0 or infinity, or if it's like a x minus 2 in the denominator.
Yep, yep. Everything, all of the integration looks like
Yeah.
regular old integration. And the plugging in the 1 was regular old fundamental theorem. It's just where that problem is that you have to look at it as a limit. Because actually, if we didn't look at it as a limit, when we tried to plug in 0 for this, it's undefined. Because the natural log picture, if you look at a little natural log picture, it only approaches 0 from one side. So you have to stop the problem. That's why we have that extra little definition about what to do with the impropers. Okay. You